So with the explosion of large language models, we've seen a surge in what's called agentic workflows and frameworks. Names like Autogen pops up, or maybe Crew AI, and even Agency Swarm, okay? These have been popping up left and right. Even LangChain, which started as a tool for building LM application, now has its own way of building agents. Now, these agents have been built around the core idea of chaining multiple agents together, creating a multi-agent framework in a way that allows them to reason and determine the next steps in the workflow. It's like creating a team of AI specialists, each with its own role and expertise, working together to solve a complex problem. Now, for example, Autogen, developed by Microsoft, pioneered multi-agent interactions. It allows you to create complex workflows where multiple AI agents collaborate, each handling different aspects of a task. Crew AI is built on top of LangChain, and it follows a similar approach, letting you design agents with specific goals, and even backstories. Now, don't get me wrong, these tools are impressive and can create really cool creative outcomes. But here's a catch, and it's a big one. Most of the processes in the real world that business want to automate, they don't actually really benefit from this level of creative freedom. In fact, it's quite the opposite. When you're working with businesses who want to automate their processes, what they usually want is a clearly defined process that makes it more efficient. If the process isn't well defined, the first step is to define it clearly, and what we call SOP, standard operating procedure, okay? Then you want to figure out the exact sequence of steps needed to automate the workflow. And then we're going to be talking about how you can expand commonly validated workflows like ETL, extraction, transfer, load, what we use in data pipeline flow, use that instead as a building block to build your agents. Now, if you want the exact step-by-step system, I'm going to leave the link in the description somewhere. Now, here's the thing with agent frameworks, and we're going to talk about first principle thinking, which is necessary when you're building agents. And I'm also going to be talking about the components of the agent. So you can ask yourself, does this agent meet this criteria before calling it an agent, okay? Now, let's talk about the problem with many agent frameworks, okay? These agent frameworks, or the multi-agent frameworks, they introduce a level of complexity and unpredictability that can be at odds with what business actually need. They're often built on abstractions that other developers came up with in a field that we're all trying to figure out. Okay, so when you're building complex frameworks, you're building on top of layers of abstraction that you probably don't even understand. You don't understand the code base, neither can you explain and communicate to the business what this actually does. And then you end up either buying or selling a chatbot or an automation or a multi-agent system. And let's be honest, it's really hard to grasp all the intricacies of a new complex library that you didn't write yourself. Okay, now with the advent of AI assistant coding, you can even create your own custom agent frameworks, or even you can use OpenAI Assistant API with some function calls. I'm also going to dive into that later to help you understand how you can start simple and then build it up to a complex machine learning agent. Okay, you could do all that with AI assisted coding, so you own your code base and you understand it, it's low code, and you can explain it to businesses. Okay, so this is what you really want, and that's why we need to go back to first principle thinking. First principle thinking is about breaking down a problem to its most fundamental truth and then reasoning up from there. It's about questioning every assumption and not blindly following the crowd or adopting systems that have not been validated yet. In the context of AI development, this means asking yourself, do I really need a multi-agent framework for this task? Am I solving the problem that actually requires this level of complexity, or am I just using it because it's the new shiny thing in the AI world? Among the agent frameworks out there, I generally choose Agency Swarm, but it also requires you to have a complex problem that you are solving with multiple agent systems. So it does not confuse the models. It doesn't add too much complexity. It doesn't, you can also explain this, okay? But even the creator of Agency Swarm have mentioned that the reason why they created this was because one single assistant would hallucinate when it's doing more than 5 or 6 function calls. Now that you know this, you might even ask, well, what if the assistant is better now at doing function calls with the structured output? Now it does not hallucinate it anymore and call 20 functions without any kind of hallucination or hesitation. Now you can chain this together into a custom agent workflow yourself just with one single agent, okay? Over-engineered frameworks like Crew AI and Autogen for your AI agent projects. Feeling overwhelmed? So I made a video, why Crew AI is obsolete. I talk about how you can build your own multi-agent system, your own custom framework with just one single agent. You can chain the function calls together so that it orchestrates the exact task that you want to do. Okay, start with the task first and then build the solution around it, not the other way around. Don't start with a complex framework. So the conditioning is deep because in the video itself, we had people ask, bro, do you have any idea about Agency Swarm or Agency Framework? I say yes. Which one do you prefer? Agency among Crew AI, Autogen for beginners. Then I said, did you watch my video? Or read the title, right? Because in the whole video, I'm explaining why you don't even need frameworks at all. You can just use a custom agent framework, or you can even start with a single assistant and build a custom agent framework with AI assisted coding. Okay, so this is the whole premise of the video. Now, the reason why there's a lot of conditioning and there's a lot of confusion in the marketplace, because a lot of people don't approach this with first principle thinking. When I'm building agents, I look at the fundamental truths that make it an agent. I constantly ask myself these questions. Does it have these things? Now, you could start simple, but expand on this as you go. Don't call it an agent when it's a chatbot. Don't take an automation and then call it an agent that does not do function call, that does not have RAG, or does not have machine learning, okay? Automation and data pipelines are a good place to start. It defines a clearly defined task, but then you need to wrap it into a function call. You have to have the agents call these as functions. You do not need an agent framework to build agents. You can just build a simple custom agent framework with OpenAI Assistant API and function calls. Start with simplicity and move to complexity as needed. So if you're a beginner, you should not even touch multi-agent system in the first place. I teach all that in the accelerator, how you can follow step by step. So there's more sauce in there. Complex frameworks and trying to fit your problem into it. Start with the problem and build up from there. What are the fundamental steps needed to solve it? What's the simplest way to achieve each step? This approach not only leads to more robust and efficient solutions, but also ensures that you understand every part of the system. Now, in my decade of experience working with AI, machine learning, etc., and even since GPT 3.5 came out, most applications follow a simple pattern, okay? Input, processing, and output. This input is your data, your prompts, your raw material you're working with. Processes, this can be simple as a single LM call, or it could involve multiple steps, including LM calls, intermediate function processing, external API calls, and so on. Output, this is what your AI creates. It could be text, code, analysis, whatever. Typically want to store this output, make it available to a front end, or use it in some other way. So if you use automations, you understand that you have to take in an input from a system, process it somehow, and then send it as an output to another system, okay? They follow the same pattern, the generative AI app workflow. That's it. It's a simple flow, but it's powerful enough to handle most AI tasks you'll encounter. Now, let's contrast this with a multi-agent system. And it's very important that we call it a multi-agent system because there are multiple agents together, and single agents don't really follow this pattern. We'll talk more about what the components are of a single agent so you understand you can just achieve a lot of these things with just function calls, okay? Not adopted from the lens of agentic framework because it might be deceiving. I want you to see the lens of an agent, of a single agent, so you can actually understand the components. Okay, so the traditional or the commonly QAI, Autogen, all these agentic framework, they have a flow as well. So this is where things get a little bit complex. You have multiple agents, each with its own goals and tasks. There's usually some kind of manager or orchestrator coordinating these agents. The output is the final result when all the agents have done their part. While this can lead to creative and sometimes impressive results, it also introduces a lot of complexity and potential points of failure. Now, you've probably seen the Strawberry model from GPT come out recently, and it already has a reasoning model built into the architecture. Granted, it takes a lot of tokens, but it also has pretty good reasoning that they do not need multi-agent system, that it can break down the task in simple steps for it to either do function calls or, split the process into a chain of thought prompting technique. As you know, the agent framework or the multi-agent systems are pretty new, not validated, and you might not even need it at this point, right? So let's talk about the data pipeline flow. This is a standard ETL flow, and this is already established for years. We have well-established principles, design patterns, and approaches for building robust, scalable data pipelines. By leveraging this knowledge, we can create AI systems that are more reliable and easier to maintain. In the data pipeline approach, your design and workflow has a series of sequential steps. Each step takes an input, processes it, and passes the result to the next step. Extract, transfer, and load. Very similar to input, process, output. The beauty of this approach is the simplicity and predictability. If your pipeline reaches step 3, and you know for certain that steps 1, 2 have already been processed successfully, this makes your system much easier to debug and maintain, okay? And you could think of this as an automation workflow, right? You can see in your automation if something something passed successfully, something failed, and then you can go back and debug when necessary. Now, I want to clear up a common misconception. Just because you're chaining together multiple steps in a data pipeline doesn't mean you're creating an agent. Most people confuse data pipelines or simple automations with agents, but an agent in the AI sense needs to be more specialized, typically involving things like RAG, function calls, and possibly machine learning models. Otherwise, it's just going to be a chatbot. A lot of you marketing guys are just using the OpenAI assistant without function calls, without RAG, without good prompt engineering, and you're calling it an agent. You could be just getting the job done with a simple LLM model and chaining them together, creating that same ETL pattern that I showed you, right? The data pipeline flow. What we're really talking about is a starting point, okay? Automations, this is great. You've started somewhere, you've defined the task. It's a way to clearly define a task or a series of tasks. As your needs grow and get more complex, you can always add more sophisticated elements to your pipeline, but you do not want it to be too complex because then you cannot put it into an agentic system. Because think of these as tasks or for an employee to perform at a specific role. Okay, so then you go to system actions for agents. Okay, now this is where agents can actually call these actions in whatever order they choose, whatever sequence they choose. You can think about agent for content creation. I'm building something similar for myself, which I will introduce you to at some point. But think of the agent performing these tasks. You know, it understands when to perform this task, and these tasks can be clearly defined as step 1, 2, 3 that you can also understand in the process. Whether you're writing these tasks with automation or with code, it doesn't matter. But as long as you understand it and it's well defined, that's all it matters. Okay. But the agent needs to connect back to these tasks so that it can call them through function calls. Okay. Repeat after me. Function call. For this, I want you to think deeply where you resonate. Okay. You might even say, Imtiaz, how dare you talk about this? How dare you? I've been using Creo AI and I've been doing this and that. It's great. I'm not saying it's bad. It's great too. I get a lot of ideas and stuff like that. It's just not validated. And we want things that are validated, and we want to start simple and not complex. We don't want to start from the tools. Rather, we go back to the first principles to understand what the agent components are. Okay. Now there's a reason why OpenAI calls their agents assistants. Okay. Because you need to build on top of the assistant to actually create a specialized agent. And the assistant API is backed up by developers and a lot of funding. So you know that it's already validated. It's already working. People are building applications on top of the assistant API. So I recommend you start with the documentation, how assistants work. I have a lot of videos explaining the components of assistant, threads, messages, run steps, all the features that go behind creating an assistant. Now, if you go to my accelerator program and you look at Unleash Your AI Agent course, I actually teach you how you can build your OpenAI assistants following a step-by-step process so you can actually scale it and at some point create an agent of yourself for yourself. And then I'll give you the practical sauce you need to start building and deploying from day one. And then we have some bonus monetization where you talk about how you can actually start selling, because selling itself has different principles that you can use. And also there's some communication aspect that goes behind selling agents. You have to be careful. Otherwise you might end up building chatbots. You need to communicate effectively the value of agents to actually start selling 6-figure solutions for businesses. Let's talk a little bit about the agentic components. Okay. You need to be constantly asking yourself these questions. Does my solution meet this criteria? This is the complete component that you need to think about. Drop the frameworks and start thinking about the components and applying first principle thinking. We're also going to give you some practical sauce, how you can get started with maybe a custom GPT, build an assistant, build an agent, okay? Follow a step-by-step process. Don't start with complexity, start with simplicity and build on top of it. All right, let's talk about the agents. What are some of the components of the agents? Now, LangChain has a lot of documentation around the components. I've taken a lot of inspiration from that, as well as OpenAI Assistant API, build agents with assistants. There's a lot of things in place that you can use to start building it up. And you can use AI-assisted coding to actually start building it up. But you need to ask these questions to make sure that it is an agent, all right? So let's talk about the AI agent components. First of all is perception. So it's the agent's ability to gather information from its environment. In AI systems, this could involve processing text inputs, analyzing images, or interpreting data from various sensors. So you might have noticed GPT-4o, Claude, or Gemini, they're multimodal, okay? Meaning that it can take image, it can take audio, it can take video, etc. And then some even generate video, audio, text, all that kind of stuff, okay? So it is the perception. It's how it perceives the environment. And think of the agents as you as well. Think of the agents as humans as well, or employees as well. Employees are humans, but their senses they have, touch, smell, sight, all that kind of stuff. Similar thing, you have to ask what senses these agents have. Next thing is the prompt, and prompt is like the instructions for your employee. It gives the employee step-by-step things to do, and might even have some goals, communication guidelines. You can give examples, how to talk. This is all the instructions for your digital employee. Okay, how to carry out these function calls, or maybe carry out tasks. Maybe it's a content creator agent that writes scripts, that publishes video, etc. What order should it perform this task? Everything needs to be defined in the prompt.
Right.
Maybe this week, what is working next week, what is working the week after. And you can take yourself more and more out of the picture and let the agent really figure it out.
Like, let's say there's like 10 combinations of things and maybe 2 of them, but let's say 3 of them work way better. They get way more views. Well, those are the 3 in phase 2 that it's going to start modeling. It's going to start, okay, this is the working set. Now let's just slightly alter it, because we just want to replicate what's working. And I think phase 2 should be analyzing and scaling, or like analyzing data and fine tuning almost, right? Like phase 2 is fine tuning already, like, because it doesn't take a long time. Like, once you start seeing what's working, just double down on it.
Now there's memory. Memory can be short-term or long-term, and these components allow the agents to retain information for immediate use and store experiences for future references. If you want to start simple, just start with the OpenAI Assistant API. They've actually built a lot of these things, just use their building blocks to start applying memory from day one. So for example, the assistant has something called thread, which stores the user assistant conversations. Every time you talk to the assistant, it understands, what you're trying to do, etc. And that itself is context or short-term memory. Now, if you want to train the agent further, you can store these short-term memory somewhere, maybe in a vector database, and then the vector database understands throughout the length of the conversation that you had with the assistant, how do you approach the problem. You can even use that to fine-tune your LLM model. There's a lot of areas you can take this, but understand you need to have memory to some extent to give the agents more context to the task that you need to perform. Now, knowledge base, this is the agent's repository of information, including facts, experience, rules, etc. Now, it can be programmed into the prompt itself. It could be programmed from the chat interaction. We can just dump it into a database or some sort so that it has the long-term knowledge. And it could start from a simple PDF file or a Word document that maybe you're familiar with the custom GPT. It's not necessarily a vector database. It's just a simple keyword search, document storage that eventually you want to scale it to a vector database that can store a lot of files. In the current OpenAI Assistant API, they use file search, where you can store up to 10,000 files. There's other open source systems or other providers that you can use for your vector database. But vector database can store image, video, text, whatever, and the agent can derive meaning from those. It can understand context. What is the meaning of the text behind these documents? Okay, that's more context to the agent. When you add something called knowledge base, you're actually applying something called RAG. So it's taking bits and pieces of knowledge from these documents, augmenting it with the LM model. So the LM model can get more kind of like context, of other sources, not just the general intelligence that it was trained on, to make it a little bit more specialized. So you actually need to eventually scale up to a RAG vector database solution, whether it's a PDF, whether it's a vector database, whatever. Or some people might even use Perplexity to do searches with function call and then augment the agent with that specific knowledge, okay? It has to augment your agent. Otherwise, the agent is going to be a statistical average of all the queries that it has been trained on, okay? So it's just going to give you a watered down response, no real sauce, okay? You need sauce. So the RAG is going to give you that practical sauce. When you're actually building assistant, it doesn't come pre-built with learning, but you can apply machine learning 2.0 so that the agent continuously learns. When it starts off as an assistant, it's still somewhat of a chatbot because it's not really specialized. It doesn't really learn from its conversation. You can use fine-tuning, RAG, and even self-learning systems so that the agent continuously learns and develops. You do not need to start with a learning system. You need to gather enough data points, good data points first, and then train your agent on those data points. You might have noticed the GPT, the new model, the Strawberry, and it has reasoning baked into the LM model. But you can also apply reasoning using simple models like GPT 3.5 by putting the assistant or OpenAI assistant right here in a loop. So output goes back to the main assistant. and it tries to think whether it had successfully solved the problem. If it didn't, it will try to redo the problem again. It's a more simple way to start prototyping your agents, start adding these reasoning components, use a low-cost LM model, so you're not also spending a lot of money, because the GPT, the Strawberry model, could incur a lot of token costs. So you need to really pay attention to that as well. Then you have action selection. Okay, so this component chooses the most appropriate action based on the agent's goals, current state, and predicted outcomes. So this is what I was talking to you about, function calls. Okay, the assistant has the ability to do function calls in the API, and it's one of the tools that are already baked in or built in. You can actually call APIs and other tools, wrap it into a function, and port it into the assistant. So the assistant can be actually very versatile. It just depends on your imagination. You just read the documentation. You can easily build the tools. I already built out a simple code base for you, so you don't have to like recreate the wheel. You can just use my code base that I use to do these function calls, and just use a template to crank out these functions on the fly using GPTs and AI assistant coding. So you can just copy and paste. Communication is a big piece, and I do advocate human AI collaboration, because communication components allow agents to exchange information and coordinate actions. All right, so at the end of the day, the agent still needs your sauce. It still needs the humans to be involved. So if you're specialized in certain areas, you need to provide feedback. The human communication is absolutely important. Now, if you're building multi-agent systems, you can also incorporate this communication, so the agent talks to the other agents in a way that it's viable. They solve the problem. It's not wasting time. Think about like the water cooler chats. You want less of that, and you want more the business meetings. Okay, so the communication is the key here. Of course, the ethical reasoning and the guardrails are also built into that aspect, and the security aspect of the agent. So when the agent is communicating to the user, it also understands, the end user also understands what information it needs to present, and how, what tone, what manner, all that kind of stuff. The ethical reasoning is also important. So ask yourself these questions as you're building the agent framework, okay? When you're actually asking these questions, that's when you're actually going to get insights. And you have to fall back on the first principle thinking. And again, like I said, these agent frameworks are great. It'll give you ideas. I would even look at something like Replit Agent, right? Now you can actually see how these agents are actually performing in a production environment. What Replit has done is added the agent into that environment, meaning the agent can write code, it can debug code, it can test code, etc. Right? These are all function calls. Then it has ability to think, it can reason. Sometimes it's slow, sometimes it's fast. But there's a lot of things that goes into the agent, but you have to ask yourself what they're using. Not really think from the lens of frameworks. Rather, I want you to think from the lens of the problem. And if that problem requires you to go deep into complexity, do you even need the agent to reason? Do you even need the agent to do function calls? Start asking these questions, okay? And maybe start with the custom GPT and see where it goes. Drop the silly chatbots and start understanding whether a simple solution can solve the problem, and then expanding to assistants. And I have more resource how you can start, turning GPTs into assistants, maybe assistants to agents, etc., and give you more practical sauce in my accelerator if you want to streamline your journey and cut through the noise. And then eventually you need to ask these questions. Does it have perception? Does it have LM? Does it have prompt communication? All these things, right? You need to think about it and then communicate effectively to the business. I hope this video was useful to you. If you like this video, if you like this kind of content, make sure you like, subscribe, hit that notification bell so you get notified every time. So I hope you like this kind of content. Make sure you like, subscribe, hit that notification bell so you get notified every time I drop a new video. So watch this video to understand the difference between machine learning 1.0 and machine learning 2.0. You can start thinking about scaling your agent from day one, and watch this video so you can understand how you can fine tune your GPT-O models and create GPT-4 you. This is Imtiaz, your top partner to build, deploy, and sell reliable AI agent systems. GPT pioneers, let's go.